Hi guys, my name is Alicia Hopkins and this is my Neurons During Action Potential presentation for my Week 5 discussion. So to start with, this is the neuron anatomy I wanted to go over. So this is going to be our basic little neuron. These little tentacle looking things are going to be our dendrites that lead into our cell body here. This is going to be our axon. The little white pieces covering it are the myelin sheath. That is a fatty substance that covers some neurons, but does not cover all. When it is there, it does help the action potential travel faster, but we'll talk about that a little bit more. These are going to be the terminal branches and terminal buttons. So as you can see, these ones are all connected. This is the way neurons connect. They connect through a tiny synapse, terminal buttons to dendrites. So when an action potential happens, the dendrites accept neurotransmitters from the presynaptic neuron. They send little neurotransmitters with positive and negative charges in through the dendrites, and they collect in the cell body. So once the cell body gets to a -55 voltage, it'll send an action potential, which is an electrical signal through the neuron. So it'll send these little vesicles full of neurotransmitters inside of it through the axon. And like I said too, if it has the myelin sheath, it'll travel faster through it, but it'll still travel without one. So through the axon to the terminal branches, and then through the terminal buttons to another synapse. And then this is going to be so whatever one is sending the action potential is the presynaptic, and then whatever was receiving is the postsynaptic. So presynaptic, postsynaptic. In this closer up version of the terminal buttons, this would be presynaptic, postsynaptic. But this is going to be the terminal branch, terminal button at the end. And then like we talked about, these are going to be the vesicles that have the neurotransmitters in them that are being pushed through the electrical signal. So they are pushed through here to this synapse, which is going to be this little empty space here. And this is going to be receptors on the neighboring dendrite. So these little receptors that you can see, there's not a lot of them. So what happens is these get pushed through, the little chemical release helps them through the tiny little synapse. They try to be taken into this neuron, but if they are not taken in for whatever reason, then they go through a reuptake period where they're actually taken back into the presynaptic neuron so they can be stored and prepared for the next action potential. This is actually going to just be another image of the reuptake and of the little terminal buttons. I put this on here because I'm a really visual learner, and it was helpful for me to have a different type of illustration, one that's like a little more cartoony and different, so it's more memorable. So again, we see the vesicles with the neurotransmitters going through the terminal buttons by electrical signal through the presynaptic neuron, and then the chemical release pushing them across the little synapse to the receptors of the postsynaptic dendrites. So the little neurons are going across, and in this illustration, they made it seem as like the reuptake ones are going to be the little yellow ones. So it's like little UFOs essentially are going to be reuptake back into the presynaptic neuron. So after an action potential, the neuron goes through a refractory period. Like I said, once the neuron reaches the -55 voltage, the action potential starts, but before that happens, it's at a resting potential at -70. So once it gets those neurons in there, the neurotransmitters, into there and gets to the -55, the action potential starts, and this would be the action potential. And the way down is called a refractory period, and that is just the process of getting back into resting potential. And as you can see, we dip a little bit below, that's relative refractory period, but same process, we're just trying to get back to resting potential so that we can start another action potential. And then like we talked about, the neurons connect to each other. This is just like a vast picture of it, so you can see how intensely they connect to each other and like how many different ways they can. And this is just going to be a cute little neuron guy. Again, I'm super visual at the way that I learned, so it helped me memorize although it's not super accurate, it helped me memorize the anatomy of a neuron. So if we think of this little guy, hair is dendrites, the face and the head of him is going to be his cell body, his actual body being the axon, and maybe if he had like a little pooch to him, that would be his myelin sheath. Little legs are going to be terminal branches, little feet, terminal buttons. And then for the citations, I'll link it as well to the discussion, but just for the sake of citations, here are those in alphabetical order. I have the images as well as the information that I'm using. And yeah, I think that's it. Thank you guys.